Hi, so this is Dr. Matsuko, and I'm creating this video here on my iPad to go over some examples of calculating electricity for you to help you study for your EMES exam 1 that's coming up. All right, here's a sheet with our key equations that I'm going to require that you understand and can work with, and a list of the different units and symbols that are used for these different equations. Okay, let's do a first example. In an LED, 3.5 coulombs of charge flows through the LED over the course of 120 seconds. How much current flows through the LED? How much current? All right, so this is charge, you're given time. All right, you have Q equals 3.5 coulombs, and you're given T equals 120 seconds, and you want to know I equals question mark. Right, so we actually have an equation for this, right? Current equals charge over time. Right, so current will equal 3.5 divided by 120. We plug this into our calculator here, and we get 0.029 amps. Very nice. Also known as 29 milliamps if you want to convert to milli, but amps are fine. All right, so 0.029 amps. All right, another example. A current of 4 amps flows in a conductor for 6 seconds. How much charge passes a given point in the conductor during this time? All right, so you're told current equals 4 amps, time equals 6 seconds, and Q equals question mark. We have the same equation, I equals Q over T. If we do some algebra, we take the T to the other side. We get Q equals I times T, right? Times. And so we get 4 times 6 equals 24. And the units are coulombs. So our answer is 24 coulombs. All right, let's move on. Another example here. Okay, an electrical appliance with a resistance of 46 ohms, all right, and it operates at 124 volts. A little bit strange, but okay. How much current flows through the appliance? All right, R equals 46 ohms. V, voltage, equals 124 volts. And then current equals question mark. All right, this uses Ohm's law. Our equation V equals IR. Right, but we want to know what I is. So we have to take R to the other side through division. We get I equals V over R. All right, we plug these in. V is, not 4, is 124. R is 46. We plug this into our calculator as well. 124 divided by 46. We get, here we go, 2.7 amps. There's our answer. 2.7 amps is flowing through our appliance here. Great. Another problem. Right, a coffee maker, oh, I love my coffee. Coffee maker draws 10 amps of current while operating at 120 volts. What is its resistance? Right? So I equals 10 amps, V equals 120 volts, and R equals question mark. All right, so this again is coming from our equation, V equals IR. Right, when we want to know R, so we put I to the other side through division. Again, we get R equals V over I. All right, our voltage is 120. Our current is 10. And if we do 120 divided by 10, we get 12. And that's in units of ohms. 12 ohms. Nice. All right, next one, coffee maker again. Okay, you have a coffee maker, draws 10 amps of current while operating at 120 volts. Let's look back. That's actually the exact same thing. All right, but this is a question about power. Right? How much power does the coffee maker use? Right, I equals 10 amps, V equals 120 volts, P equals question mark. So this uses one of our other equations, P equals IV. And fortunately, we don't have to rearrange it at all because we're looking for power. All right, so P equals 10 amps times 120 volts. So you get 1200, and power is in watts. 1200 watts. That's a lot of watts. Right, so that's a lot of energy at one time. Here we're looking for power again. You have the heating element of an iron. Operates at 110 volts with a current of 15 amps. And what is the power dissipated by the iron? Right, just power. All right, so we have V equals 110 volts. I equals 15 amps. P equals question mark. So we have our equation P equals IV. Again, we don't have to rearrange it. So P equals 15 times 110. I'm going to plug that into my calculator. 15 times 110, and we get 1650 watts. So, same order of magnitude as your coffee maker, but just a little bit more. Right. Oh, okay, we're getting into prices now. We're getting the cost. Right, at a price of 10 cents per kilowatt hours, how much does it cost to keep a 120 watt light bulb on for one whole day? All right, there's a lot here. Okay. Let's see, what do we got? Our price equals 10 cents per kilowatt hour. Let's see, our watts is power, right? Power equals 120 watts. And then one whole day, that's the time. Time equals 1 day. We're going to have to convert that into hours here, and that's 24 hours. Right. And we want to know cost. Cost equals price times energy. Energy. All right. Energy equals power times time. Right. So we're going to have energy equals 120 watts times 24. Right. 120 times 24. I'm going to calculate this out. Is 2880. But this is in watt hours. And we want kilowatt hours. Right? Because we have our kilo there. Kilo represents 1,000. Right? So we have to divide this by 1,000. Right? Because 1,000 watt hours equals 1 kilowatt hour. And usually our prices are in kilowatt hours just because that's how they do it. And so you get 2.88 kilowatt hour. Right? So in our equation, as I gave before, actually divide by 1,000 in order to get in the right units of kilowatt hour. Right, our cost is going to be the energy versus times price. Right, so the price here is 10 cents per kilowatt hour. Our energy is 2.88 kilowatt hours. And so we get 28 cents. is our cost. That's the total cost for having a light bulb on for the whole day, 28 cents. All right. Lastly, we get our another coffee maker. Okay, how much does it cost to run a 1200 watt coffee maker for 20 minutes each day for 1 month or for 30 days at a price of 14 cents per kilowatt hour? So actually in Boston we pay a little bit closer to 14 cents per kilowatt hour. All right, so this will be a good estimate for us. All right, so we have our power equals 1200 watts. Okay, we have our, let's see, our time. We have 20 minutes per day, right? Wow. And we need to convert 20 minutes into hours. Right, so that's a third of an hour, right? Because an hour is 60 minutes. So I'm going to scratch this off here. I'm going to say a third of an hour for 30 days. All right. So we have our time per day times the number of days. Right, that gives us 10 days. 10 hours. 10 hours. So we're talking about a total time of 10 hours. And lastly, we have our price, which is 14 cents per kilowatt hour. All right, so we're going to do the same procedure again, find out what's our total energy. Our total energy is going to be the power in watts multiplied by the time. We're going to divide by 1,000 so we can get the right units. So we get 1200 times 10 divided by 1,000. Right, and so that becomes 12,000 divided by 1,000, and that is 12. So the total energy we're talking about is 12 kilowatt hours, and your cost equals your energy times the price, and so you get 12 times 14. That also, plug this into our calculator, and we get 168 cents, which is the same thing as $101.68. All right, so your cost per month to run this coffee maker is going to be $1.68. All right, so that's it for our examples. I hope this video helps you. Please feel free to reach out to me or others if you have any questions.